Before I think we are going for the next session, let me invite Keysight NIT Delhi. They have signed an MOU for exchanging the MOU jointly developing OTFS technology which will be used for 6G. So I invite Keysight representative IIT Delhi to come on the stage and exchange their MOUs. This is something example of global collaborations when technology developed by IIT Delhi is being transferred to Keysight. So this is, I think, first they are utilizing our platform for exchanging their MOUs, which is for the transfer of OTFS technology developed by IIT Delhi to Keysight. A big round of applause, please. Thank you, IIT Delhi, and thank you, Keysight. Thank you all. So now I request my next is. Thank you, thank you. So I request now let us begin the next session. That's the first session by Professor Bhaskar Ramamurthi. Sir, may I now request Professor Bhaskar Ramamurthi along with his team, Professor Herald Haas, Dr. Osako Iwao, Dr. Magnus, Dr. Sus Datta, and naturally our chairman, Professor David Coyle Pillai, on the stage. And I request others to kindly take your seats. Please take your seats. And we are starting our first session. That is a structured session on discussion on 6G initiatives across US, UK, Japan, South Korea, Europe and India. I am sure that our distinguished speaker, they will be sharing their R&D schemes in the different part of the world and how India can learn certain lessons. Let us begin with this. I think I just hand over to Astha. Dr. Astha, can you, sir, I think you can start moderators. Sir, back to Professor Bhaskar. Sir, to you. We'll be just displaying their detailed bio brief we have. The moment you call it, it will be, yeah.
We can start?
Yes, sir.
Okay.
Over to you.
Very good morning to all those who are here. Welcome to this Bharat6G Symposium. We're very honored that so many distinguished speakers and participants have come for this symposium from all over the world. In fact, the very first session of this symposium, which is the panel on global 6G initiatives, has several key speakers from different parts of the world. I want to especially thank them for making the huge effort to travel all the way to be with us here today and share their deep insights and knowledge. As all of you are aware, there are several initiatives that are being spearheaded across the world in 6G, and in US, in UK, in Japan, South Korea, China, Europe, India. So we are privileged that today we have speakers representing many of these initiatives here. In particular, I want to welcome Professor Herald Haas, who represents Future Telecoms UK. Dr. Hosoko Iwao will tell us something about what the Japanese initiatives in 6G are from NICT Japan. Dr. Magnus Frodig, he is the Vice Chairman of the Hexa-X initiative that is forging ahead in Europe. Dr. Ashutosh Datta will tell us about IEEE's Future Networks effort in USA. And then Professor David Coyle Pillai, who is the chairperson of Bharat6G Alliance and the Qualcomm Institute chair at IIT Madras, he will tell us about the Indian Bharat6G initiative. As the moderator for this panel, I requested the distinguished speakers to take a few, about 8 or 10 minutes, tell us about the highlights of their the initiatives that they represent. But in particular, I requested them to focus on a few aspects, key aspects. One is, what do they see as the major focus of the 6G initiative from their point of view, from their perch? Is it speed? Is it the use cases, specific use cases that they are focusing on? Is it the new spectrum that will maybe make a huge, expected to make a huge difference in the 6G initiative? Or is it new technology, AI, ML, or whatever it is, or combination of all these? So we all are, I presume, aware of where we are today in the world with 4G and 5G that is widely deployed. We also know where some of the things in which 5G did not quite lead to the expectations that we had, or the thoughts that may have driven it, because that's the nature of these things. You know, they are these new technologies. Some things work out even better than we anticipated. Some things don't work out quite the way that we anticipated. So, or they work out a little later than we thought for various reasons. So, the lessons or the trajectory of 5G as it's emerging today is clear in front of us. So, keeping all that in mind, what I would like our distinguished speakers to, because they all have a very unique perspective on what's playing out and what will likely play out. So it will be very interesting to learn from them where they see the pivots happen or likely to happen for 6G, whether we will see AI ML actually make a huge difference, or we expect to see AI ML make a huge difference, or maybe a new network architecture, maybe the new semiconductor breakthroughs that might make some difference. So this is really what we are looking from this session. Get some insights maybe from the 5 or 6 experts that we have here on where 6G might actually have a departure from the trajectory that we have witnessed of the way 4G and 5G has gone. So with this request that I made to these 5 experts, let me go in the order in which they're listed in this schedule. No particular reason for this order except that it's printed here in that sequence. I now request Professor Harold Haas to take the floor first and share with us his perspective from UK on 6G roadmap and the initiatives that they are taking in future telecoms. Thank you.
Thank you, good morning, everyone. I'd like to basically start by really thanking Bharat6G Alliance and the organizers for inviting me to this very esteemed panel this morning today on discussing very, very important topics. I'd like to really preface my talk by saying that it is really important that we collaborate internationally in 6G and beyond, because what we are doing is we are creating the nervous system that it should be available to all on the globe, and also we need to have a single nervous system to unlock its full potential. I think to that end, it's really, really important that we have come together and work on 6G. We know that every generation has its paradigm shift, and maybe at least every even generation has a paradigm shift, and maybe it's a paradigm shift of the 6th generation to go from bit streams to data and the meaning and the AI. And that creates a lot of interest in terms of how AI will unfold in standards and how AI will be changing the networks. Can I also take the opportunity today, when we talk about collaboration, to say that India and the UK have been launching a new strategic R&D partnership to jointly develop 6G technologies, and this will be announced tomorrow. So please join the Indian-UK high-level panel at 4 p.m. tomorrow when the announcement will be made. Please give the marketplace event at 10 o'clock a.m. tomorrow morning as well the chance to join, where the opportunity arises for all shareholders and stakeholders in India and the UK to set the direction of this new, really important initiative of a joint collaboration, a joint center between India and the UK. So that a strong partnership between the two nations are really coming out through this partnership. So I'd like to then now briefly go into highlighting a little bit the activities in the UK and what the UK has done in the area of 6G. And to this end, I'd like to highlight that there's been about 75 million US pounds that have been developed, invested into 4 telecommunication hubs that are led by Cambridge, Oxford, Imperial, and Bristol. And the hubs are brought together under an umbrella, which is the Federation, the Federated Telecoms Hubs, that has a major important objective, is namely to take the TRL3 research, the fundamental research in all of these hubs, and to translate it into commercial outcomes. And in fact, there are four major objectives within the Federation of the translation is given on that slide. So it is on standardization. So we really want to make sure that all the research that's coming through these hubs has an impact in standardization. We work with industry partners in achieving that. And the second objective within a federation is to create commercial impact. So we have heard earlier by Professor Song what India does, and this is a similar matched activity by creating a patent pool, by creating proof of concept projects that take low TRL research into higher TRL prototypes and sort of commercial products. We have a joint activity on standardization, on marketing, and also on skills development. And when I say skills development, we want to develop in this federation skills beyond the pure technical skills, really develop entrepreneurial skills that take the translation, the outcomes, into real commercial success. So I briefly run now through the individual hubs, and all over the entire activity is sort of encompassing 27 UK leading universities. And you see them here on that map. I'm not going into those details, but you see a major national activity in bringing 6G research together. Some of the key outcomes over the last 2 years since the federation and the hubs have been established are shown on that slide. You see we have a very strong, as we expect, outcome on scientific papers. What we try to do within the federation to match that with IPR patent applications. So we want to, or have started, to introduce a culture change in the academic world by thinking patent before paper and translating the research into invention disclosures and hopefully eventually in patents, and patents then into standardization contributions and new spin-outs. This is the kind of achievements or strategy we've adopted. I'm not going into all of the details, but briefly about Titan. It's a hub I lead in Cambridge. It's the hub on network of networks, which basically brings together network intelligence, AI, radio comms, optical wireless comms, fiber, non-terrestrial networks, and quantum towards creating a unified single network for sort of creating resilient networks, creating secure networks, creating sustainable networks, and in fact, in some ways with AI, also self-healing networks in the future. There's the hub on Cheddar, which is led by my colleague Julie Mekani in Imperial, looks at cloud computing, edge computing, with 3 pillars on human-centric and emerging system, and as well as sustainable systems. Some of the key directions this hub has taken is, for example, on going into verifiable AI. Everybody talks about AI, but the AIs need to be verifiable and need to be repeatable, and that's a theme that this hub develops in addition to integrated sensing and communications, which feed through this hub as well. The third hub is on more the physical layer side, is led by my colleague Dominic O'Brien in Oxford, and that looks at spectrum in a wider context. Spectrum in the radio world, but also looking at terahertz, sub-terahertz, across the domains of wired networks and wireless networks. And lastly, the fourth hub is a very important initiative on testbeds. It's a national infrastructure for experimentation, or network experimentation, led by my colleague Dimitra Simienotou in Bristol. It has developed 11 sort of what they call joiner nodes that are complete network nodes across all the layers, including RF, including optical switches, where really experimentation at scale could be carried out. And the plan is to have first 6G trials within this network running. The idea is as well to expand that infrastructure towards a non-terrestrial testbed. It's called the Space Lab. And there's also a national spectrum facility attached to this activity, the joint activity, where the idea is really to monitor and sense the spectrum use geographically in order then to develop policies and how to use and share spectrum, because that is a very, very important way forward in looking at spectrum sub 8 gigahertz, which is sort of the answer to some of your questions you've raised in terms of what spectrum we are using. Joiner Hub has a number of research themes that you see here, on onboarding new hardware, looking at AI, looking at spectrum, cloud edgification, as well as AI as a service. Quickly about standardization, we have identified those key technologies that are really relevant in going into 6G and beyond, and have made a map of these technologies in terms of how do the hubs respond to these technologies. And you see the blue boxes here, and you see the numbers inside, and the numbers correspond to projects within those four hubs. And you see we have a strong focus on ISAC, we have a strong focus on AI, non-terrestrial networks as sustainable networks, and we've mapped this to 3GPP activities. And this is the working groups we are currently monitoring, we are currently actively engaging in order to bring UK technologies into the standards. That is about the federation, but there's more activities in the UK on 6G, and I want to mention the 5G, 6G IC Innovation Center led by my colleague Rahim Zafarsoli, that sits here. It's been around for many, many years in helping shape generations of cellular communications through cellular, Wi-Fi, and importantly, non-terrestrial networks. And this is an additional activity that goes alongside the federated hubs. And I also want to mention, it's important in this context here, my colleague Professor Parr sits here as well, is running the Future Networks Initiative, FNI, for a long time with Indian colleagues and trying to establish these partnerships, collaborations, with an important aspect on skill development as well, because they are crucial in driving jointly the way forward. Lastly, conclude, and I do apologize if I'm running over time, is we really want to, we are open, the UK is open, and I've said it at the beginning, to collaborate in important topics such as AI, non-terrestrial networks, optical, including quantum, and we do, hopefully jointly work on joint large-scale 6G trials, joint developments on standards, and also maybe jointly developing future commercial successes in 6G. And with this, I'd like to thank you for your attention.
Thank you very much, Professor Haas, for a very crisp overview of the multifaceted efforts that are ongoing in the UK. We'll get the perspectives from all the speakers, and then we'll have enough time for Q&A. I now request Dr. Hosako Iwao to tell us what the 6G initiatives are in Japan, and I think you had the combined optical and wireless OWN in Japan sometime, yeah. So maybe we'll hear something about OWN also. So I now ask Dr. Hosako Iwao to tell us.
Okay, thank you very much for the kind introduction, and also thank you very much for the many of the organizers of this event inviting me to hear about the discussion about the future R&D of 6G. And I would like to show some my slide. Okay, I'd like to talk about the firstly our funding scheme for the R&D of 6G in Japan. And we have started our activity at 2020 and preparing for some big part of the funding for the R&D of 6G, and we call it Beyond 5G. And in such cases, we preparing for the little bit huge money for the first step. Okay, could you go to the second slide? Okay, this one. Okay, sorry about that. Okay, thank you. And okay, so we have launched the time-limited fund at first in the 2021, and in such cases we provide really huge money, and in total 60 billion yen from 2020 to 2022. And then we established the permanent fund, we called it, and it was established in 2023. And after 2023, we provide at around about 167 billion yen up to now. And the scheme is coming, the money is coming from the Ministry of Internal Affairs and Communication and to NICT, and NICT provides such kind of money to the companies and academias. And we have many of the projects at this moment. And also, in the 7G meeting in 2023 in Japan, which include a declaration of the 7G vision for the future networks in the beyond 5G and 6G. This is quite important visions for our researchers. We are thinking about to establish these visions. Okay. So now we, not only for our cases, but also many of the country and many of the researchers expecting the AI native society in the future, probably in the 2030s or something like that. And in such cases, we have many of the components, small AI components and huge AI components everywhere in the networks. Maybe in the core networks and radio access networks and also non-terrestrial networks. And such kind of society need to support a very huge traffic of the data. So it means that we are preparing for the support such kind of data traffic at first. So that's the reason why we are firstly involved in the development of all photonic networks. And we would like to use photonic technology into the future society. And also, we are thinking about some changes at radio access networks and also non-terrestrial networks. So we are concentrating on the 3 points. First one is all photonic networks. This is quite important. And this includes many of the data exchange between the data centers and also inside of the data centers and also the radio access networks. And also we are thinking about the non-terrestrial network. It's quite important. In the case of Japan, we are concentrating on the high altitude platform systems, HAPS, and also satellite communication systems. And in case of the HAPS, maybe you know that Japanese islands is very long distributed, and it's a little bit difficult to cover by only the terrestrial networks. And also we have many of the ocean areas, so we would like to cover such kind of areas by using the hubs. And also, we are thinking about new radio network systems, and we are concentrating on the sub-6, and also would like to improve utilization of millimeter wave, and also would like to install standard systems. And also we are discussing about much more higher frequencies like terahertz, but at this moment it's probably in the, not the 6G, but it's also coming in the 7G or something like that. Okay, this chart shows the profile of our grant. Okay, just a moment. Okay, profile of our grant. And left-hand side is a profile of the time-limited fund, and right-hand side is the permanent fund schemes. So as you can see here, we are concentrating on the all-opportunity networks and also radio access networks. Okay. And also, NICT itself is a research institute, so we are conducting other activities. Starting from the Japan's vision, Society 5.0, which is a cyber-physical society, we are extracting the architecture of such kind of society. And here is, okay, anyway. And from the architecture, we pointed out 3 important points. And we are establishing 3 important POCs, proof of concept, which is listed in here. And now we would like to install these POCs to the some open innovation bridge, open innovation hubs. And we plan to open the open innovation hub very close to the Tokyo station, only 5 minutes walk from the Tokyo station, and it's connecting to our test beds. So we expect many of the researchers will have an interest to come to here and working together and create new technology or a new combination of technology to support the AI native societies. Okay, thank you very much for your kind attention. And if you are interested into our visions and also some time schedules, please go to this website. But this is only in Japanese, but recent technology can easily translate it into English or your native languages. Thank you very much for your kind attention.
Thank you very much, Dr. Osako Iwao. I now request Dr. Magnus Frodig, who's the Vice Chair of Hexa-X of the European Initiative, to share with us the perspective that this European initiative has on 6G. Thank you.
Yeah, thank you very much. And it's a pleasure of being here and be able to talk to you about what we have done now on the research.
Dr. Magnus, you are quite tall, so please.
Okay. Okay, thank you. And the Hexa-X project 1 and 2 have now been finished, and based on that work and other research work, of course, I think we are starting now to see how the 6G will take shape and how it will look like and what kind of services, etc., that we will see around it. So let me share a little bit of where we are currently. So importantly, I think we are in this inflection point in the industry. We have been building mobile broadband. We have built that on 4G. We have used the first phase of 5G in order to enhance that, where we all have our mobile broadband subscription and we have sort of unlimited buckets, etc. Right now we want to shift that into something that you can get more value on top of that mobile broadband. In order to do that, we really, really need the mid-band, of course, but also then the standalone, so we can do the network slicing and network exposure out of the networks, to transform this mobile broadband subscription type of offering into a platform. And if we do that, we are seeing, of course, that we already use cases that we already talk about today that will come on top of this platform, and we will be able to scale them to offer these new use cases in a massive way, right? So let me look a little bit on these use cases. And I don't think we need to invent new ones here. These are really just around the corner. We already see them partly, right? So part of it is the mixed reality, of course. Here I think the AI glasses will come first, and then we will move into more augmented reality type of glasses. Global connectivity with the satellites. We have the first versions already now combining with 5G. They will be fully integrated in the 6G timeframe. We are seeing how we are now communicating also with drones and other flying objects, etc. So, of course, that will also be key properties of this network. We are seeing how the mission-critical networks now are being shifted over to 5G networks, and that business is of significance already. Then we are introducing new capabilities in the 6G on top of that, so we can have this sensing capability and going into all of this spatial understanding, both sort of sensing environments, but of course also being part of new, more advanced services. Based on that, I think everybody is talking about digital twins, and here we can of course think about the digital twin of the network in itself in order to make it possible to have autonomous operation of networks. But of course all other objects, industries are also creating digital twins of whatever they would like to control. And then of course if you would like to have an updated digital twin, the things needs to be connected, you need to collect data and update your digital twin. I think this is the base also for the AI parts, right? So we will use AI in the network of course, but it's of course a lot of AI agents that will need to communicate using sort of the 6G platform in order to coordinate the activities they are planning to do. So I think there is a lot of really, really strong use cases in front of us. Looking a few years ahead, of course, there will be more than this. We just don't have realized them yet, right? But we do have a significant part here. So what will 6G then bring? It will extend the end user benefits, so it will of course be faster, more responsive, but it also new support of these new device types of course. And you will have the satellite connectivity included. There are of course key technology components that we are now bringing forward into standardization. I think one important thing is the uplink downlink decoupling, where we are having the possibility to have downlink on the best frequency for downlink, and then we can take the uplink in order to use the lower bands very selectively for the most critical uplink services, for example. So this has great promise, I think. We will optimize further on the energy side. We will, of course, improve spectral efficiency. We will bring in new spectrum, etc. And based on this, then, we would really like then to have the enable new revenues. So I talked about scaling, so we would like to have these new use cases offered more massive to all subscribers. So it's important to get going, to get this traction on these things already now on 5G. And the most 5G advanced markets will of course be the ones that can take full advantage of 6G when it becomes available then 2030 and beyond. So talked about this platform. I think if you have a platform, you need to ask for services and you need to deliver services, typically through APIs. And of course, we would like to be able to receive requests for differentiated connectivity with specific characteristics. And then we will be able to configure the network, of course. It needs to be programmable in order to meet these different things in the different slices. And then from the slices, we will now, of course, verify that the ask was performed, and then we will send proof of that, and then you, of course, will need to pay extra using the network capabilities, right? Because it's important for the industry to be able to bring more revenues into the operators doing all the investments in the networks. But then we also see new sources of data. So it's not only just the communication between A and B, right? It's also the possibility of use sensing, so we can have a much richer information out of the network. Location, exact time, spatial understanding then from sensing. This can of course be delivered up through APIs. It can also be refined and delivering more advanced values up to application developers. So I think this is a fundamental of changing this into this platform instead of just communication links, right? Of course, in all new generations, the spectrum, the coordination with availability of new spectrum is always key, right? So, and we already have several different bands, right? But the centimeter, the upper 6, and then the 7 to 8, etc., is of course key. And in order to motivate investments in new networks, increasing the capacity, etc., of course, there needs to be new spectrum. And here I think all the different regions are of course struggling a little bit to get the right spectrum for 6G, but this is an ongoing process which is very, very important. So finally, we don't have standardized it yet, but I guess we have a feeling for how it could look like, right? And we do definitely see that we will improve on energy efficiency. We will make it even more leaner, so you can go into sleep modes, on lowering the energy consumption with low traffic loads. But also on the device side, with the wake-up receivers, etc., we can go even deeper in sleep mode there as well. The capacity has to be there, so new spectrum, of course, but also increased spectral efficiency. We need to bring up capacity. And I think we haven't fully utilized, of course, yet the AI capabilities, so we will see a lot of smaller AI models doing different things, enhancing performance, altogether bringing up sort of the spectral efficiency of these systems. Then I talked about the uplink. I think we can do things there, just simply coordinate control signaling, scheduling, and things. So these are in the works. And then this uplink, downlink, decoupling, really optimize the use the frequency bands in the most efficient way, I think is super important. And then we have a little bit on location and sensing and these kind of things as well. So I think we are starting to see where we are going here. That there is already sort of ideas on how this system will look like. We can start to talk about what the potential is for the performance, etc. But of course, standardization just started. We are just starting up the study items. So it's a very, very interesting times now to see how this develops and get all of this innovation now into standards and into the new release here. So thank you.
Thank you so much, Dr. Frödig, for a very insightful presentation from Hexa-X. Now request Dr. Ashutosh Datta, representing Johns Hopkins University and also where he's working, and also IEEE Future Networks, to tell us the perspective from the United States. Thank you.
Okay, thank you. Thank you very much for the invitation. And this is my second Bharat6G Symposium. I was here last year as well. I'm glad to be here. So I'll be focusing mostly on some of the 6G initiative that's happening within the United States. As you will know, whether it's 5G or 6G is an ecosystem. We cannot do it alone. We need to collaborate among each other. We need to develop new standards, build a new testbed, prototypes. Good. And at the same time, try to implement and make sure it actually works. If it doesn't work, go back and fix it and come back. And at the same time, we need to have use cases. That's important. So all this keeping in mind, I think every country is working together, which is a good thing, and Bharat6G Symposium is an important platform to help enable that. So with that, let me just move on. I can see that. Okay. So I'd like to give some sample initiative that's going on, and I try to put them in a few different categories. One is the public-private partnership, university research, standards, test beds. And there are many initiatives going on within the United States, and we are collaborating with other countries as well. The first two I highlighted, the National Science Foundation, and you can see it's a successful collaboration among the private industries, government, US government like DoD, NIST, DHS, at the same time other universities, and it has really led to a lot of fruitful collaboration. So there are two projects. One is the VINES project, which is the verticals for intelligent network systems. That means if you have this 5G, 6G coming up, how do you make sure where it can be applied? So this call for proposal, I think there are two projects, part one, part two. Part two was due, I think, September 25th. And there have been a lot of collaboration there. Prior to that, there was a RINGS project where you have to build a resilient system. So resilience is one of the pillars of 6G. So these two projects are very successful. In addition to that, the Spectrum-X project, I neglected to mention that. Notre Dame University is Indiana. They are actually leading that. And then there are several university-led researchers, and I know Charles Clancy couldn't come. Folks in MITRE, there's a AI Win joint collaboration with companies like NVIDIA, Cisco, T-Mobile. Here is a good collaboration, University of Texas, 6G at UT Initiative, Jeff Andrews and folks. University of California, San Diego, 6GI, Native Communication Networks, New York University. Many of you have attended Ted Rappaport and Nokia. They have been doing this Brooklyn used to be 5G Summit and 6G Summit. And finally, at Johns Hopkins University, we do help DSH and DoD, tactical and fast responder networks. We are doing a lot of research in this area. These are some sample examples. Then I'll come back to the standards, and I'll have some slides about that. ATIS Next G Alliance, just like we have TSDSI in India and ETSI in Europe, etc. So ATIS also has a roadmap from Next G Alliance. National Spectrum Consortium is another organization within the United States. They're looking into many of the 5G, 6G use cases. IEEE Future Networks, which I'm one of the founding co-chair. I also have Sudhir Dikshit here, one of our leader. We have been looking at some of the roadmaps, 5-year, 10-year, 15 years, how things are going to look like. We don't call it 5G, 6G, or 7G, but I know Dilip is also Dilip Krishnaswamy as well from CDOT. Then the Standards Association, were also coming up with new, they call it parts, like pre-standardization. So we have some new idea how Standards Association paves the way to take it to the standards. So these are some interesting opportunity where we can collaborate. And then I talk about test beds. I think many of my previous speakers, they spoke about test bed. This is the important thing. While you build the standards, build the technology, at the same time, we need to show how it works. So NSA Platform for Advanced Wireless Research, this has been a big successful collaboration. 5G, 6G Innovation Test Bed that IEEE recently built. If you can go to D25 in Hall 1, we are making it open neutral test bed so people around the world, academic startup, they can get access, the students can get access, and in addition to taking the theory, they can really build hands-on experience. Open RAN, OTIC test beds, there are many of those. Open RAN Alliance within the United States, there are 5 or 6 different OTIC test bed where they can see how Open RAN can actually work and integrate with 6G code. NTIA test beds, the BID program, they also have a broadband initiative. Many of the universities like Accord, Valor, and DIS projects, they are working on it. So I'll just briefly flip through it just to give you an idea. This is the NSF VITES program, industry partners, Ericsson, Intel, Qualcomm, international partners like Finland, India, some of you are probably here, Japan, Sweden. There are federal partners like NIST, OUSD, Research and Education, and Department of Homeland Security. So this is a successful collaboration. The whole program's objective is to really look at the fundamental research and try to see how the 6G type technology can be applicable to different types of verticals like agriculture, health. So you should not be just telecom centric, right? That's the whole idea. So I think people are already collaborating it, like to see more of these kind of programs coming up. And Next Year Alliance, and this started about 4 or 5 years back. Johns Hopkins is one of the contributing member. Again, if you look at the main objective, research initiative, development, manufacturing readiness, standards leadership, market readiness, and finally also deployment. There are many reports coming up out of it. There are like 6 audacious goals, they call it, in terms of roadmap, technology, security, application, sustainability, among others. So these are the reports. I know there are probably few sessions. Amitabh might be talking later on more detail into 6G, Next Year Alliance, what we are doing there. IEEE Future Networks, this is something we started a few years back. And this is a technical community now. We do several different things. Future Network World Forum coming up in Bangalore next month. Connecting the unconnected. Sudhir and I have been doing a lot of work to address the digital divide, a lot of webinars, test beds. And most importantly, we are developing the roadmap, 3-year, 5-year, 10-year down the road, how things are going to look like. These are there are about 14 or 15 different working groups. And this is free, open to all. Anybody, any student, faculty, researcher can join and start contributing. The next edition of the roadmap is coming up. So, application security, testbed, millimeter wave, among others. So you can see energy efficiency, anything that we need to build a 6G ecosystem. Next one is testbed. I have 3 more slides. I finished. The testbed side, you see, this is one of the very successful public-private partnership, and there are 4 different testbed now. One at Powder, Salt Lake City, Cosmos, New York City, at Columbia University, and Rutgers Main Lab, Airport Research Triangle Park in North Carolina State. RI is the rural. So when people build some prototype, they can go there and try to do the scalability. We did that for Department of Homeland Security. We did some proof of concept in the lab, then we went to Cosmos and Utah to see how it can be done. So these are the kind of things we should be doing, not only do in the lab. I know in India there are many test beds being built, and I think it's very important. This is something I wanted to say. The IEEE 5G6 Innovation Testbed, I'm one of the co-chair. I'm very passionate about this. This gives a chance to do hands-on work of people around the world. You're a startup, big company, small company, academics. You can collaborate, and this become like a hub and spoke model. You can do things here, take different use case. At the same time, you can collaborate with others. So please try to take advantage of this. And there are many other partners we have. Some of them are also over here, a lot of open source as well. The last 2 slides, I wanted to talk about IEEE data port. This is a very interesting thing. Dr. Rakesh Kumar, he couldn't come. When we do, data is very important, right? So you need data, you can also export data. So IEEE data port is a very interesting platform where if you're doing, let's say, work on intelligent transportation system or 6G or agriculture, right? You can import data from this and run your experiment. Or if you have interesting data, you can export it, and all your data get archived, and they get also citation, just like your IEEE paper gets cited. These data somebody uses get citation. So I would urge people to take advantage of that. There is just 2 use cases I wanted to show here. National Institute of Technology, Meghalaya, and they did some air quality data set. So the reason I'm showing here, these are another tools what we have at our disposal, which we can take advantage of. And second one is Mizoram University, and this is around AI-driven crop recommended. This is for agriculture. So since 6G is not only focused on telecom only, there are many different verticals. I just wanted to show you what's happening in United States and how we can collaborate with other countries, other organizations. And I wanted to highlight several pillars. It is the collaboration, standards, testbed, proof of concept, and look at all the verticals. With that, I end my talk, and I'll be happy to talk to anybody after the talk, and I'll be here for 2 more days. Thank you.
Thank you, Dr. Saraswatosh Datta. Now we come to the last speaker. Bringing up the rear is Professor David Koilpillai, Chairman of the Bharat6G Alliance. He's from IIT Madras. So David will tell us about the perspective that India is taking in their 6G initiative. Thank you.
Thank you, Professor Bhaskar. Good afternoon, ladies and gentlemen. Very happy to have this opportunity to share with you a brief glimpse at what the path to 6G looks like from an India perspective. I'll start with the three points that we are keeping in mind as we talk about 6G. One is ubiquitous coverage, second one is sustainability, and the aspects of affordability. So this is sort of woven into our discussions on 6G. The Bharat6G Alliance has identified these as key functions that we need to address as we look at 6G, aspects of spectrum, devices, technology, applications and use cases, and sustainability. So these are how we are structured and how the work is progressing. And our input to the government at this point has indicated that there are three major focus that we have to look at. One is what we do in standards towards 6G, what we do in terms of R&D within the country and in collaboration, and what is the support that we need from the government in terms of policy. And along with the Telecom Standards Development Society of India, we have identified a number of areas where there is current technical activity within 3GPP and also interest within the country. So again, I have listed these layers. Probably in addition to the list on the left-hand side, you would probably see some points which were touched upon by my colleague, Professor Rohit, saying that we are also looking at developing components, modules, which are needed to support the ecosystem as we develop it within the country. And he also mentioned about how we will work with the hub and spoke model within the country. As mentioned, we are looking at a phased approach. The standardization in 3GPP has already started. ITU work is in progress. So we need to start the work right now. So that is phase one, where we're looking at R&D, looking at the pre-standards prototypes, and also some spectrum-related activity. This will lead to phase two and phase three when we get into the deployment stage. So as all of you are aware, we are very much in the thick of things as far as 3GPP is concerned, as far as the discussions for WRC 27 are concerned. So in that regard, the activities within India are also aligned that we are able to participate in these activities towards Release 20, Release 21, and also WRC 27. In terms of spectrum, India is in a good position. We have the entire band that will be discussed in WRC 27, starting all the way from 6.425 to 8.4. That band is of interest and is currently under discussion in India. We do have some incumbents, but the government is committed to ensuring that we have sufficient spectrum, both for the cellular technologies and also for the unlicensed. Both are being supported, and we believe that we are aligned with Europe and many other countries around the world. So we also are very happy to have a number of our international partners with whom we are discussing on the roadmaps for 6G, especially looking at the issues of spectrum. What are some of the use cases, because monetization is an important area, and we want to look at that and also look at some of the collaborations in the area of technology. So with that, let me summarize by saying this panel and this conference is coming at a very good time. We are very much in the race for contributing to in the 6G area, looking for definitely active interaction and collaboration with our partners, and always ready to share with you what is happening within the Indian ecosystem. Thank you very much.
Thank you very much, David. So I thank all the speakers for staying within the time limit. We started a little late, but I think we're catching up. Before I throw the hall open for questions, let me just quickly summarize a few points that I haven't been able to capture in the last 1 hour listening to all our experts on the dais. I'm just putting together a few highlights that I heard, and these are a mix from various speakers. I think I sort of also remember who said what. So I think from Dr. Frodig, we saw that we expect a doubling of the downlink speeds. I mean, that's what the target is, right? All right?
Yeah.
specifically, I think with new spectrum and improved spectral efficiency, where the total capacity in both uplink and downlink would improve significantly. And I think we need to have a strong focus on this, because to utilize the spectrum assets in the best possible way. And going from these different generations, of course, we are using more and more of the technology, so it's getting more and more challenging, of course, to find these improvements. But I think we are on a good way of doing that.
Okay. I also heard from you that we can expect pretty good resolution in with ISAC, maybe 3 meter or less, by the time it stabilizes and becomes.
Yeah, I think this will depend very much of the use case. And detecting drones then a little bit above the clutter is of course a very good first use case, and there I think, depending on the density of the networks and the frequency used, etc., is definitely possibilities to get very accurate. Then you have much more challenging use cases as well, and I think we need to deploy something, we need to learn, and then we need to gradually improve. So I see a journey in front of me here for the different releases of 6G, how we gradually will be able to improve and provide value in more and more advanced use cases.
So I did see a mention of digital twins on several presentations. I think Professor Haas mentioned it. I think, if I'm not mistaken, so did Dr. Osako, then Dr. Frodig. So digital twins, particularly massive digital twins, seem to be a focus in many, there seems to be a convergence among all the speakers. NTN, of course, satellite-based NTN is almost like a no-brainer, but I did see a specific deadline for the trials of HAPS-based NTN from Japan, 2026. So would you like to say something more about that, the HAPS-based NTN?
Yes. Yeah. For Japan, for the Japanese society, HAPS is more important because I already said that the coverage of the very huge areas of the ocean and also very small islands is quite important, and it's possibly to cover by the satellite system, but we would like to think about the HAPS system first. Yeah.
So 2026, you expect to have some trials?
Excuse me?
2026, you expect to have some trials?
2026, maybe the first demonstration will be done.
Okay. So we'll all look forward to that. Energy savings, of course, is holy grail for everybody mentioned it. And I'm sure there will be something that will come from all the initiatives. But one thing I would like everybody to do is to also, I want to say that we must look at the energy consumption in the context of per capita energy consumption in all our activities. And whatever numbers I have done, despite the huge increase in energy consumption, when you look at what is consumed in every tower, I think the per capita energy consumption in telecoms is still very small, a fraction of what we consume as a human being in all our sum total every day. So I wouldn't fret too much about it, but it is important to do whatever we can. Spectrum, I think I could see that underlying, everybody recognizes that as we go to the higher frequencies beyond 3 to 4 gigahertz, propagation and everything becomes harder. So with millimeter wave, we did have a reality check in 5G, and but there is going to be centimeter wave. That's the name that I saw today in Dr. Frodig's presentation, around 7 gigahertz. That also is not going to be a cakewalk. Particularly, I can tell you that in countries, tropical countries where you have during rain, where the raindrops are quite big, I think we have seen with satellite that even 6 gigahertz, goes through a dip goes through an extra loss. So I did see the idea of delinking the uplink and downlink spectrum, so that the downlink probably doesn't have to deal with as much of the higher spectrum losses due to higher spectrum, because downlink is power limited. I'm sorry, uplink is power limited. And so that idea, is it something that we're going to see in 6G, sir? From Dr. Frodig, I saw it in your presentation, delinking of uplink and downlink.
Yeah, I think this is one of the key flexibilities that we are introducing now, going from 5G to 6G, and that really requires this shift to a new generation in order to decouple uplink and downlink, because that affects all the protocols, etc., right? So in order to have that flexibility, I think we can use the combination of the spectrum assets in a more flexible way.
But do you actually see a reallocation of more uplink spectrum in the lower frequencies than what is there today? I mean, traditionally, uplinks have always had less, I mean, in the FDD they were all equal, but in the TDD case, the uplinks have always had less spectrum.
Yeah, so I definitely see that the new services that we see in front of us with AI glasses, etc., they will send more in the uplink. And in order to get the responsive experience as a user of these glasses and get the responses in sort of real time, you need to have a better uplink. And then, of course, if you then can use your uplink resources in a more flexible way, that will sort of increase the total performance of the network. And typically then, since you are power limited uplink, you would put more uplink on the lower frequencies.
On that topic, one last question, related question. In TDD, of course, we get tied up completely with the requirement for coordination among all the users, all the operators on the uplink downlink ratio and the synchronization. But on FDD, do you think we can get to the point where even the direction of the link, whether it's uplink or downlink, is left to the operator, or do you think we'll still have to have coordination?
Yeah, I think the main coordination is needed for the downlink resources between the macro base station that do have line of sight. So that needs to be taken into account, of course. But then uplink, you might have more flexibility to schedule.
We also heard from both Professor Haas and from Dr. Sacco about this, about the focus on optical and quantum computing, and also networks, and also all photonic networks. So would you like to say something about that? Because we saw from both of you.
I think in the context of non-terrestrial networks, the optical spectrum is, in my view, quite important. And we see, for example, with Starlink, they already have satellite-to-satellite communications in using optical domain.
Free space.
Free space optical domain. And the same applies for satellite to ground. If you mentioned sort of the resilience, you can't rely on a single link because you have atmospheric effects. So that's why it's good to look at wider spectrum in terms of getting spectral diversity into the system. And then also in terms of terrestrial networks, you've seen companies like Tara looking free space optical communications to connect the unconnected in a terrestrial way, building fixed point-to-point communication links. So although it's not within the standardization bands, the optical domain, but we'll see more optical systems coming into our spheres. And personally, I mean, you know, I've been doing a lot of work on Wi-Fi, and we are looking at sort of terabit Wi-Fi indoor access networks, utilizing that huge unallocated or unregulated spectrum in the optical domain.
Yeah, I think given your pioneering work in Wi-Fi, there's no doubt that for indoor communications and so on, free space optics has really a lot of promise. But on the somewhat longer distance outdoor, we've been hearing about free space optics for decades. So because there's a cost issue, there's a complexity issue, deployment simplicity issue.
I think it's more a commercial issue. If you look at the attenuation, you have a very positive window, so sub 10 gigahertz. But then if you look at beyond 10 gigahertz to sort of tens of terahertz, you see a lot of attenuation, especially in sub-terahertz in the spectrum. So the attenuation goes down to 0.1 dB per kilometer again in the optical domain. So it's a very nice window to use optical spectrum for free space communications. Of course, you have to deal with the turbulence effects, with the atmospheric effects, but that is achievable, and there's a lot of research on sort of optical MIMO systems as well. So these are technical solutions, and I think there's a great market for that.
Good. I'm glad to hear that there's that we can look forward to some new breakthroughs there. Dr. Iwao Hosako, what about these all-photonic networks? Because I think your OWN forum was actually the first to push this very hard.
Yes, and from the many of the aspects, the all optical network has many advantages over the electrical connections. So that's the reason why we are concentrating on that. Because of the capacity and also energy efficiency and more suitable for the short-range connections for the inside of the data center and the data center between the data center connections. So that will support the AI-based, AI-native society in the future. That is quite important. And also many of the optical connection in the space connection by optical space connection also probably very useful because it's relatively depending on separating on the radio frequency loss. So we can utilize such kind of optical connection in any of the opportunities inside of the building or outside of the building. So that's the reason why we are concentrating.
Professor Datta is fixed wireless access. Of course, we heard this also being mentioned by Dr. Frodig, but or maybe it was, yeah, I think it was him. Is it something that's a lot of, I hear a lot of interest in the US because of the use case or need?
So that's kind of the low-hanging fruit anyway, right? We got to tackle that. That's obviously the most popular thing. If you think about whole mobility and things are still being worked out, if you're handing over from one cell tower to another cell tower, how do you optimize your security and mobility? And at the same time, if you think about 6G, ubiquitous connectivity is another big pillar. When you are moving from cell to Wi-Fi to satellite, I think the whole NTN and terrestrial integration is so important. I personally did work in a Department of Homeland Security project where if you have a priority on cell and something happened to the cell tower, you move to Wi-Fi, how do you still maintain the same quality of service, same priority? I think that seamless connectivity is important. So while fixed wireless, obviously to get the maximum bandwidth, but at the same time, how do you make sure you get similar quality of service as you move around? I think that's the interesting research challenge we should be tackling.
Okay. I think we're ready to take questions. So we'll start with our lady here in the first row. Please, can they get a microphone? Asta, can you get a microphone there?
You can come from here.
Hello, wonderful panel. Thank you very much. Very interesting topic. So my name is Meri Helle. I'm a semiconductor entrepreneur. I come from Finland. Yes, I worked for a short while at Nokia in the past. But we are working with microelectronics manufacturing in the RF components. So have any thoughts about the availability of RF components, and especially for telecom infrastructure? So I'm sure Qualcomm's and Broadcoms get it all right for the mobile devices where the volumes are, but how about developing RF components, filters, switches, amplifiers, antenna tuners, and also passive components? So what are your views, and especially how could we collaborate with US, Europe, India, Japan to bring these components to the markets?
Before I ask any of the panelists if they have thoughts on this, I want to share with her that tomorrow at 1:45 there's a session on semiconductor advancements for 6G readiness. Okay, but does anybody have anything to say today? Yeah. David?
I would definitely echo the sentiment that the components ecosystem really needs to be built up. That is one of the focus areas from within on the Indian side, and my colleague Professor Rohit will be able to add some more information. We are in the process of identifying who are the players in this area. It's a field that is coming up, but we feel that it's an extremely important area. Thank you.
I'd like to add one thing to the, sorry, Amita. I want to say that NICT, the CHIPS Act in the United States, since you mentioned, obviously it's going to be renamed, but that's still an initiative where we can collaborate on that.
Yeah. I
think it's an important question, and in the UK we're looking at new materials, gallium nitride-based power amplifiers, also for the solar hardening. So when you think about satellite communications, it's an area there's a lot of work in the UK.
Yeah, thank you to the esteemed panelists. I have a two-part question. The first question is that the US MNOs want to deploy 6G in the existing grid and existing 5G grid, right? And to do that, you see, they want to exploit the uplink coverage, so they want uplink coverage, extreme MIMO in the 7 gigahertz band, energy efficiency in AI native, what Magnus mentioned. The question is that with the latest bill in the US, this is US question, one big beautiful bill, you see, you have 800 megahertz of spectrum, but the spectrum is fragmented, right? So you don't have in the 7 gigahertz spectrum 400 megahertz per operator. You get only probably at the best 50 megahertz per operator. So how do you handle this fragmented spectrum where you have spectrum in the 2.7 to 2.9 in the C band and in the 7 gigahertz band for 6G, so that each operator gets more than 400 megahertz?
During their presentations, we did hear about, I did hear about AIML for spectrum sharing. I heard from somebody, and intelligent spectrum sharing and so on. So maybe, I think it was you, Dr. Frodik, maybe, or you can try to take the answer. Then, and Dr.
We all
Datta.
spoke about AI to some extent. That's true.
Yeah.
There are 2 or 3 initiatives.
So go ahead. Then I think Dr.
No, the
Frodik-
Spectrum-X, I was talking about Spectrum-X and MITRE guys, they're doing this AI stuff, I think. Those are the 2 initiatives that come to mind.
Dr. Frodik, please.
Of course, I think it's important with the spectrum sharing, right? So you can introduce 6G in already deployed 5G bands and then gradually switch over to 6G as you get more and more traffic. So the spectrum sharing will of course be a key property of the new standard. And we need to do that much more efficiently than we did from 4G to 5G. So that's of course one thing. Then the spectrum is still equally fragmented, of course. So I think we are still sort of working on getting primary spectrum. That is the best, and that's the sort of the first option for us. Then of course we need to look at how we can use secondary spectrum as well. And then you get into those different AI methods in order to understand the availability and how you can coexist with other services. So I think we need to be prepared to look at all of these opportunities.
I have one, I have one related question, derived question. Just a thought experiment. If we were to press the reset button and start all over again, and if we had all the money and all that, and we could do it very quickly, if we could lay out completely new wireless networks, and all the spectrum that's already been assigned, just that, no new spectrum, from 700 all the way up, if it was continue to be available, would we do it very differently? Will a new net, using all the bands that have been allocated for mobile communications, if they was continue to be available, but we could completely redo the networks, would the way the spectrum be used be very different? The various bands? Any ideas on that? Have anybody thought about that? I mean, would all the lower frequencies be given much more for uplink, and then would something like that be done? Yeah, go ahead.
I think it's a difficult question because the mobile networks emerged from mobile telephony, which by nature is symmetric, to mobile data networks, which by nature is asymmetric. In the past, we have more downlink heavy load. Now we see more uplink heavy load. I guess one of the key advantages of TDD is exactly the time division duplex, is to be flexible in the uplink downlink assignment, and probably it would be good to use systems more on a TDD mode, but then you need to coordinate interference, and that is where AI can come in and do it intelligently, because spectrum is not always used around a country all at the same time in the same way, and if you know how it is used, you can do more intelligent spectrum sharing.
My questions are pretty broad, so just wanted to understand that if one is implementing 6G, how much of 5G infrastructure is getting used over there? How much would be the incremental capex or we'll be just upgrading 5G to 6G, or it will be totally new capex. That's one. Second, building on his question, if we say 6G has to be thought totally differently, say AI first. So AI is first and then everything is built on top of that. So how much of AI is being used in 6G?
Who would like to?
Yeah, I can start.
Because you'd like all more capex, I presume, but
Yeah, but we also need to be, of course, what the industry can afford. So the migration is, of course, a key part, and I think we do need to go to new spectrum. And if you go to new spectrum, you need new antennas, new radios. So there obviously will be additional equipment needed. Then, of course, the expectations on data rate and performance, that could be partly, of course, handled on existing infrastructure. But gradually, of course, that also needs to be replaced. So I think we will try to offer a smooth migration, but still sort of put the bar high in order to reach the performance requirements, not only in 2030, but in 2035. So it's very, very difficult to say what that will look like in 10 years.
yes.
Yeah, so I'd like to just, I'm sorry, go ahead. Magnus? Okay. Can I speak? Okay, I'll be brief just to answer. I mean, I used to work for AT&T before I joined Johns Hopkins, so we have seen the whole transition of 4G to 5G, even the whole virtualization, slicing, etc. And I was in the 6G workshop in Korea, kickoff, and they said, okay, when you go to 6G, there is no standalone. I mean, in 5G, you have a 5G standalone, non-standalone, right? So they say, okay, we'll just go for 6G standalone. That means we'll be building everything native 6G and maybe AI for network for AI, embedded AI agents, inter-agentic communication. So this is how 6G is looking into, right? So from the get-go, just go 6G. I just wanted, yeah, go ahead. Yeah, CapEx, OpEx, obviously we have to keep that in mind. Obviously, we have to do economic analysis there, yeah.
Most of the operators have a replacement cycle, so they would probably looking to merge this with that, I think.
I think it's a very, very important question, and I think there's a lot of value in current networks to increase the value with things like AI you've mentioned, but there's also challenges coming with that. For example, a data pipe in Tokyo is the same as a data pipe in the US, but an AI model in Tokyo might be different to an AI model, training data for the AI model in the US. So the question really is, we have this sort of idea of a global network where AIs are trained in a different way. How do we make sure that we have a global single network? And that's, in my view, the challenge if you think about this added value of AI. But yeah.
Thank you. Professor Parr? Yeah, I'll come.
Yeah, thanks, Oscar. And just a turn to the panel, if I could. Gerard Parr from UK IFNI project. A term that hasn't been mentioned is cybersecurity. So as we look at the integration of all the optics, cellular, mobile, subsea, satellite, who is responsible for maintaining the security of these integrated networks?
I can briefly talk about, I used to open Chief Security Office at AT&T. As you mentioned, I know we didn't put too much discussion about cybersecurity. Security monitoring, universal monitoring at different over the RAN, core, edge, and having the ability to correlate if there is an attack coming from somewhere, right? From where it is coming, what the IP, MC, IP address, all those. Again, when I mentioned about Department of Homeland Security project, one project I was involved to look into those, right? So each organization, each operator, they have their own security requirement, but you have to follow some sort of a recommendation, either national recommendation or things like NICT. I was talking to a gentleman this morning from India, Department of Telecommunication. They are doing the certification. So, and each access may have a different access. So we have to look into those and come up with some kind of a centralized monitoring, getting the data from different parts of the network and correlate that. Control plane, data plane, denial of service attack, man-in-the-middle attack. I mean, you have to build the whole threat taxonomy, come up with a mitigation technique, and do the what mitigation technique can work, what doesn't work.
Yeah, I would like to complement a little bit. I think it's very much an ecosystem here. I think vendors like Ericsson and we will of course work in our capabilities in standards in order to increase the security, the robustness of the systems. But then it needs to be deployed in the right way. You need to have, of course, security monitoring. You need to do the applications in the right way, etc., etc. So it's really a end-to-end and ecosystem challenge, I would say.
I think we'll try to wind up in 5 minutes. So quick question, two of you.
Yeah, I'm Dr. V.N. Sastri from IDRBT. We work on the 5G use cases for the banking sector and also looking forward for the 6G. But my question is, what are your thoughts on the migration path from the device point of view, from the services point of view? Because what is most important is how the 3 billion customers, when they migrate to 6G, do they have to throw their devices and purchase new devices, or is there any thoughts which they can use just by replacing some components or some services only with the affordability that they can have?
Yeah, I think migration path will probably be very similar to what has been adopted from 4G to 5G, but
yeah, I agree. I think when the standards are ready and we will gradually see then chipsets out of the Qualcomm and the like, and these will then gradually then be 6G ready. And then while you are using these devices, the infrastructure will be built out, and then gradually you can use the new 6G capabilities. And of course, if there are huge benefits that you see that you as a subscriber would like to be part of new services where 6G is needed, then of course at some point you need to get the 6G capable device. I think the 5G devices will continue to work on the 5G level, right? But they cannot be software upgraded to fully use the 6G. So I think you gradually need to shift out and shift in the new devices, but it doesn't need to be overnight. I think we will build up that fleet of devices when you anyhow would like to buy a new device.
the last question, please, because we have to wind up.
Yeah.
30.
Good afternoon. I'm Dr. Pradyumna Kumar Patra from NICT University. It is not my question, it is request. My request is, let's say we are talking about industry 4.0 or 5 point. In future point of view, where if we talk about this application part, then a lot of struggle we have till now in India to get the spectrum. The private 5G network is concerned, or application is concerned, or industrial automation is concerned. When one organization is going to install some use cases, in that organization, a lot of from spectrum point of view, they are struggling a lot. So my request is, why kind of US severus spectrum band, how they are getting the at free of cost. So that kind of band, if in India can be included as a industry application, that would be a means one milestone achievement for the.
Thank you, David. I think you are chair of the working group. He's talking about the difficulty of getting spectrum for private networks.
Yeah.
And
I think
yeah.
it is a topic under discussion in DOT, and they are actually considering the dedicated band for that. So that's something that may be resolved very, very soon. And we have experts from WPC in the audience, and I'm sure you'll be able to get but it is a topic of discussion. It's recognized as a need, and it is being addressed within India.
Okay.
Thank you.
So I know that there may be others who have questions to ask, but I think we just have to wind up. We had the luxury of eating into the networking and lunch break, but we can't push this too far. So I want to first thank all the panelists for being so generous with their time and willing to sit here beyond the scheduled time slot, and for all the insights. At least I learned a lot from many of these presentations. I tried to jot down what I learned and share it with you. So I want to thank Ashutosh, David, Magnus, Dr. Sako, and Professor Haas, and all the audience for being so enthusiastic. So thank you very much on behalf of Bharat6G Alliance. I commend you to lunch and the next session. Thank you.
Okay.
For that, hand it over.
So thank you, Professor Bhaskar Ramamurthy, sir. I will request moderator to present a token of appreciation to each panelist, starting from the first panelist, Professor Harold Haas. Please, quick round of applause. Next is Dr. Hosako from NICT, Japan. We have Dr. Magnus. Dr. Ashutosh Datta. I invite Professor David Kolpillai. And I request our chairman, Dr. David, to please present our memento to our moderator's chair, sir. Okay, thank you all. And I request you all to join us in the networking dinner, networking lunch, sorry. Thank you. ये boxes में